All right, welcome back, guys. We are doing 2.1 notes today, quadratic functions. Now, this lesson today might get a little long just because I need to go over completing the square. But I'm going to do that with the examples that we're doing. So keep that in mind. The other thing I like doing is kind of splitting your page up into these are the things and steps I need, where this is the work that I have on my side. Because what happens technically is when you start doing work in between all your steps, you get confused of where you're going. So hopefully I can organize you a little bit more. So let's get started. All right, quadratic functions. The most basic quadratic function, of course, is x squared. That's your parent function, so it has it right here. So what we're going to do is we're going to graph the function g of x using transformations, and then we're going to determine that vertex. Even though some of you might know this already, we're just going to think about this. So on the inside, we are going left 2 and down 3. Sorry, that noise, that's my printer. All right, so if I were just to move this parent graph left 2 and down 3, so I'm going the parent of 0, 0, left 2, down 3, we end up with something like this. Okay. So if you remember, the vertex is at max or min of the parabola. So this vertex here is -2, -3. Okay, notice that we can identify transformations in vertex form. This is why it's called vertex form, because we can see the vertex. Now keep in mind, opposite H, same K. I'm using H and K because that's usually the form of the vertex. So vertex is usually in H, comma, K. Okay. And you'll see down below that our vertex form that's standard, you have the H and the K. So let's look at those down below. Okay. So here we have a form. This is standard form, but it's not our standard, or it's called general form. General. Well, let's keep it as general. A lot of teachers go back and forth on what standard and general is, because I used to say this is standard form. As you can see, I said it just a few seconds ago. But we need to learn how the questions are going to be asked. So this quadratic function is in general form. Okay, just like this one up here, x squared plus 4x plus 1. All right, that is general form. Now standard form, meaning vertex form, I like vertex better, is our a times x minus h plus k. And that shows the vertex. So I'm going to write this in case I go back and forth, because I'd rather call it vertex form. Okay. Now, I want to point out something. You see how both of these equations have a? These are the same numbers. Okay. As you can see, there's no b and c in here, and that's because as we rearrange it, those values change. And the vertex form shows us the vertex. The general form, really all it gives us is the y-intercept, which is c. Okay, so let's keep in mind some other things that we might need. Sorry, my camera ran. The quadratic formula, there's my printer again. The quadratic formula helps us find our x-intercepts, okay? So I'm going to write that down. This helps us find our x-intercepts. From a general form. So when you have it in general form, you can use the quadratic formula to help us find our x-intercept. But here's a side note. if you can factor it to an a times x minus p times x minus q, if you can factor it, the p and the q are also our x-intercepts. So only use the quadratic formula if you cannot factor it, because factoring should just be a natural flow right now. And that's easier to find the x-intercepts. So let's be careful of that. Now, some of the things about the quadratic formula that might help, because of course a parabola could have 2 x-intercepts, 1 x-intercepts, or nothing. It doesn't hit the x-axis whatsoever. The best way to know how many there are is to use what we call the discriminant. The discriminant is b squared minus 4ac. And again, you get the a, the b, and the c from the general form. Okay? Now, the one thing to keep in mind if you want to know how many solutions there are is if the discriminant is less than 0, there are no real solutions, okay? Less than 0 are negative numbers. Well, that makes sense because we can't take the square root of a negative number. See how the discriminant is what's under the square root. So that makes sense. Now, if the discriminant equals 0, there is one solution. Okay, because of course, square root of 0 is 0. So when we're plus or minus in 0, we come up with the same number. If b squared minus 4ac is greater than 0, then there are 2 real solutions. Again, because if you take, let's say, the square root of 16, you get 4, but we're adding 4 and subtracting 4, giving us 2 values. All right, the standard form of a quadratic function. So let's talk about this a little bit. Vertex formula for quadratics in standard form. So of course, this is our standard form, or in my terms, vertex form, because it gives you a vertex. Okay, now, this is all your papers I'm printing out right now. So what we want to keep in mind, the other thing is the vertex, again, is the min or the max of our parabola, okay? If A is less than 0, it's upside down. Remember, less than 0 means negative. If A is greater than 0, which is a positive, then the vertex is a min, and it goes up. The other thing I want you guys to keep in mind is the axis of symmetry, right? If this was the point HK, the axis of symmetry is H, okay? So that's the X value, the Y value. So the axis of symmetry is going to be X equals whatever number H is. Okay, it's a vertical line, so you must write it as X equals whatever that number is. Symmetry, of course, is where that you can fold it on itself. Everything on the left side is the same as the right side. All right. Now, this is where we're going to get into the nitty-gritty on things, okay? So pause if you need to, write down questions if you need to, review it again if you need to. First of all, what I like doing is when I read a question, I want to make sure I label everything I need. So right here it says convert the functions below from general to standard. That means I'm going from this form to a times x minus h squared plus k. This is where we need to complete the square, okay? So now it says find the vertex. So I'm going to label this first. We want the standard form. We want the vertex. We want the axis of symmetry. I'm going to shorten this, guys, so that way I have room for my work. And we want the x-intercepts, y-intercepts. All right, and I'm also going to, since I know I just need these things right here, I'm going to do all my work on this side. So I'm actually going to put a line down, and maybe even down here in case I need the room, okay? So this is my answer to the question. But all my work to get those answers are going to be over here. Now, one of the things I want to point out before we do anything is we already have one of these by looking at this. Do you know which one we have? We have the y-intercept. The y-intercept is when x is 0. So if I plug in 0 to this equation here, I get the value 3. Y and x intercepts are coordinate pairs, guys, so you have to use them as coordinate pairs. Okay, you have to write them. You don't just give me 3. Now it looks I didn't read all the directions because I need a graph. So what I'm going to do is save this down here for the graph. I'll just make it super small. Okay, we'll see what happens. Okay, so all of these, well, these first 3, I need it in vertex form to do this. But the x-intercepts, maybe let's get those out of the way first, okay? Just to get them out of the way and we can focus on completing the square. X-intercepts, I gave you 2 ways you can find them. Quadratic formula or factor. Again, quadratic formula, I think there's so many steps that you can take that would allow for mistakes, where factoring is a little bit better, okay? But if we wanted to see how many solutions there are, we would say negative b minus 4 times a times c. If you see, this is 16 minus 12, which is 4, and 4 is greater than 0. So remember, if it's greater than 0, we have 2 solutions. So we should get 2 x-intercepts, okay? X-intercepts are when y is 0. Okay, I'd rather factor. So if I factor, what 2 numbers do you multiply to give you 3, but add to give you negative 4? It'd be negative 3 and negative 1. So what 2 things make that 0? 3 and 1. And that's our 2 x-intercepts. All right, let's get to completing the square. Okay? When you complete the square, you're going to want, there's 2 ways you could do it. I'm going to try to show you the faster way. Okay? Just the non-confusing way. So the first thing I do is I take this value of c and I bring it to the other side. So I have x squared minus 4x equals negative 3. Then what we need to do is take our b value and divide it by 2 and square it. Okay, when I get that value, that goes right here. And now as you can see, since we're squaring it, it will always be a positive. So negative 4 divided by 2 is 2. 2 squared is 4. Okay, always do this. This is b over 2 squared. Okay, that will always give you this value. Now, we've been balancing equations for years. Whatever we do to one side, we have to do the other. So I'm going to add 4 also to this side. okay, to keep it the same. Now, the reason why we do this is to get a square here, because we can factor this and we get x minus 2 squared. Now, yes, you can factor it and say it's x minus 2 times x minus 2, and we can square that together. Or what we could do is just say that this value, not squared, goes right here. So -4 over 2 is -2. And of course, I combine in like terms here. Now, we're not in that vertex form yet because we need to move this one back over. Okay. The reason why I moved it to the right side and then I have to move it back is because I like the idea of whatever you do to one side, you do to the other. Now, you could have kept it there, but you have to put in the opposite. That will make sense if we ever run into it, but I like this way. It's more organized and you remember what we've been doing for years. Whatever we do to one side, we do the other. So that means if I subtract 1 to both sides, I get our vertex form, which is x minus 2 squared minus 1. And don't forget, this is f of x. These are the same equations in different forms. Now, this allows us to have our vertex. Remember, the vertex is h comma k. So it is going to be opposite to what we see on the inside, so 2, and the same on the outside. So our vertex is 2, -1. The axis of symmetry is always a line, so it's x equals. And what is the x value of the vertex? It is 2. And we've got all of our pieces. Now we can graph. Okay, I'm going to label each piece. And then it says determine its range. Okay, so let's plug these in. Let me do this. So the vertex is at 2, -1. Our x-intercepts are at 3, 1. And our y-intercepts at 3. So here is our parabola. There we go. And we're all set there. Now, let's do our range because that's what it asks for, range. Now, range, remember, is how far down to how far up. So how far down did we go? We went to -1, and it goes up to infinity. Parentheses, always around infinity. And did it get to -1? Is that filled in? Yes, it is. So we have our bracket. Okay, even if you're like, oh, this is easy, I got this. What I want you to do is make sure you go over this next example with me because it's completing the square. It kind of has fractions in it and there's a negative right there. So it gets a little confusing. You want to be able to go through all the different circumstances that we can run into. So let me label everything we need to do. Standard form, vertex, axis of symmetry, x-intercept, y-intercept. This time I'll remember to have my graph. And then our range. All right. Whew. Let me make some room. Okay. Before we get started, this is not in correct order. X squared will always come first. So I'm going to put it in order. We get -x squared minus x plus 6. Okay. Now remember, there's one thing we can get right off the bat from this form, and it's our y-intercept. It's when x equals 0 and we get 6. Okay. The other thing I want to point out right away before we do any work is which way is this parabola going to face? Is it going to face up or face down? It's going to face down because it's negative. Now, one of the ways to find the x-intercepts, right, is to factor it. But when you guys factor, you have to remember to take out that negative. This needs to be a positive in front of the x squared before we can factor it. So I'm going to take the negative out, and I get x squared plus x minus 6. Now I can factor. I have that negative out front. What two numbers multiply to give you negative 6, but add to give you 1? So that is going to be 3 and 2. And then since the x is positive 1, we have a positive 1, negative 2. So that makes our x-intercepts -3, 0, and 2, 0. Awesome. I mean, you could start labeling that on your graph if you choose so, but that's up to you. All right, now we got to go to completing the square. I'm going to use purple and pink again because that's what I used above. So I am actually going to start with this. Nope, I'm going to start with this. Remember, the first thing I did was I moved that 6 over, or that c value over. So negative x squared minus x equals negative 6. The next thing you're going to want to do, just like we did before we factored, is we have to get rid of that negative. Okay, so, or at least put it out front. So you get negative x squared plus x equals negative 6. Okay, do not factor out that negative when completing the square until you move that c over, because we just want this involved. Okay, now we take our b value, which is 1, divided by 2, and we square it. Well, unfortunately, that's still a fraction, so it's 1/4. Now, remember, the next step is whatever we do to one side, we do to the other. Here's the idea. You have to interpret that anything out front goes with that value. Okay, up here, we didn't have to worry about it because it's 1 out front, and anything times 1 is itself. So in actuality, I'm not putting in 1/4. I'm putting in a negative 1/4. Negative. If this was a negative 2 out here, I would be putting a negative 1/2. So you have to multiply that out. So on this side, I have a negative 1/4. Whatever I do to one side, I have to do to the other. Okay. Now I can make this a perfect square, right? So I have that negative out front. It's going to be x squared right there. Remember, it's this value in here. So it's plus 1/2. And on my calculator, I can do this with the fraction. Or you can do it in your head. It becomes negative 25/4. Now remember, I have to move it over to get my vertex form. So I end up getting negative x plus 1/2 squared plus 25/4. And then, of course, this function is g of x. Okay, and that's completing the square. Now, from there, what is the vertex? Remember, it is opposite to what is on the inside, which is negative 1/2. Same on the outside, which is 25/4. Axis of symmetry is x equals, and the x equals what in the vertex? -1/2. All right, let's graph it. Of course, I'm going to graph my intercepts first because because they are integers, it's just easier. So x-intercepts is 2, 0, -3, 0. Now y-intercept is 1, 2, 3, 4, 5, 6, 0. Now, -1/2, so it's right here, and 25/4 is 6 1/4, so it's going to be just right about here. Now, if you look, when you put, sorry, I've been doing this and I haven't, there we go. If we connect all these, didn't we say at the beginning that our parabola would be upside down? And look, it is upside down. It is awesome. Let's talk about that range. Okay, so range is from bottom to top. Well, if you look at the bottom, it keeps going. The bottom then keeps going to -infinity, and it goes all the way up. And where does it stop? It stops at the value of 25/4. It hits 25/4, so that's a bracket. Awesome, guys. Sorry if this is getting a little bit long. I just want to make sure that completing the square is all set. All right, so if you want to get into the nitty-gritty on how things are set up, instead of solving for or completing the square and all that stuff, this is where everything comes from. But I wouldn't go into that, guys. I think that's too much. I would rather you just complete the square, and that will look out great. So let's talk about this. Vertex formulas. So if you have it in vertex form, you have an HK right there. But if you have a general form, another way that you can find the vertex instead of completing the square is doing -b/2a. That's your x value. And what you would have to do then to find your y value is plug in the -b/2a. So that is another way that we can find the vertex, and we are going to practice that down below. So that's going to be up to you what strategy you use. Now, this also works too if one you think at completing it in the square or you get those fractions, okay? So to graph a parabola, so we either have the two forms, okay? We can find the vertex. We're going to try finding the vertex right now with the -b/2a. And then the axis of symmetry, of course, is that x value. And then we're going to find the intercepts, additional points. If there's no x-intercepts, you still want to plug in some points, okay? And then we're going to draw everything. All right, so let's look at what we want. We want to find the vertex, axis of symmetry, x-intercepts, y-intercept, and then graph. Okay, one of the things I want to point out, because what's great is that we can find the vertex using -b/2a in this case. And the reason why we don't have to complete the square is because it doesn't make us do it in vertex form. Now, if the question, like on the other page, said find it in standard form / vertex form, then you would have to complete the square. But if all we're doing is graphing, you do not need to complete the square. All right, so let me divide this up so I can see my work. Okay, so vertex, remember it's -b/2a. So I'm going to put the negative, B is 4, 2, and then A is 1. Again, I'm getting that from A, B, and C. All right, so negative 4 over 2 is negative 2. All right, so right away, guys, that is the x value of my vertex. To find the y value, we plug in negative 2 for x, which gives us negative 2 squared plus 4 times negative 2 plus 7. Okay, and that value gives us 3. I'm giving it to you. You can plug it in a calculator or do it in your head. So the vertex is at negative 2, 3. Axis of symmetry, of course, is that x value. Let's do y-intercept really quick because, of course, that's when x is 0, and when x is 0, we get 7. Now, x-intercept. Okay, we do not have it in vertex form. It doesn't, well, vertex form doesn't matter, I guess. It's not factorable, right? There's no two numbers you can multiply to 7. That gives you 4. So we would have to use the quadratic formula. Well, instead of doing the full quadratic formula, let's see how many solutions there are. So remember, that's with the discriminant. So that's negative b minus 4ac. What does that give us? Oh, and by the way, that's what? B squared, right? B squared. Sorry, B squared. So, not negative b. I was thinking negative b because of the quadratic formula. Sorry. Discriminant is b squared minus 4ac. There we go. All right, so we get 16 minus 28, which of course is a negative 8. No, negative 12. Can't do things in my head right now. And that is less than 0. Well, what did that mean? That means no real solutions. Okay, so I want to show you a trick. Let me graph what we have so far. So we have our vertex, which is at negative 2, 3. And we have our y-intercept at 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Okay. The great thing about parabolas is since they are symmetric, I can see that since the y-intercept is 2 away, it's also going to be 2 away on the other side and up at the same point. So it's not another y-intercept, but it's a reflection of it. Now, if your problem asked you to label 2 more points, you're going to have to plug in any number and find what that value is. But the good thing about it being symmetric is that we just have another point reflected on the other side, and you're done. All right, I told you this lesson was long. I'm sorry, guys. All right. The weekly profit in dollars made by selling X Portaboy game systems is P of X, blah, 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 with a restriction. So we can't go lower than 0. We can't go higher than 166. Graph this, including the y and x intercepts and the vertex and the axis of symmetry. So I'm going to label everything we need, so I remember to do everything. Axis of symmetry, x intercepts, y intercepts, and the graph. Okay, label my work. All right, from here, it does not have us put it in vertex form, so we can just use our negative b over 2a. So it's negative 170 over 2 times negative 1/2. Now remember, I told you we're going to start using decimals and stuff, so make sure you have your calculator out and do not use a graphing calculator because you don't want to depend on looking at that stuff. You want to use the calculator you're going to use on the test. Okay, so if you do this out, I'm actually going to keep it in fraction form right now so I don't have to worry about repeating decimals. Not to mention is because this is the x value, and to find the y value, I have to plug in. It's easier to use the fraction than the repeating decimal because you might be estimating. So when you plug in 170 over 3 for each of your x's, do not forget to put parentheses around the fraction itself. So I want you to try that out really quickly. Pause the video, try it out, and hopefully you come out with this answer of 14,000 over 3. Okay, try that. Make sure that you're plugging it in the calculator correctly and ask me questions if you cannot get that answer. All right, and then of course the axis of symmetry is x equals, and it's that value of 170 over 3. Okay, let's do the y-intercept really quickly, which is 0, negative 50. All right, nobody wants to try to factor that. It's not factorable. You have to use the quadratic formula. So I'm going to show you how to put it in, and then I'm going to show you how you want to write it instead of estimating it out, okay? So I get negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now, what I suggest to you is first simplify that out and simplify that out. Okay, I'm going to keep it approximately right now. Okay, so when I do that, if I can grab my calculator really quick, 170 squared minus 4 times negative 1.5 times negative 150, even though I only wrote down 15. Okay, green. Okay, what I am going to do is actually write this in one form, and I'm not going to simplify all the way. So it's going to be negative 170 plus the square root of 28,000 all over negative 3, comma 0. And we also have negative 70 minus the square root of 28,000 all over negative 3, comma 0. Okay. Now, what that looks like is you want to make sure that you are estimating your graph. Okay. Before I graph, actually, what I'm going to do is we're going to interpret the zeros. So if you plug that into your calculator, remember it's not equals, it's approximate, and we get 0.89. So when you actually plug one of those in and the other one, you get a 12.44. Okay, so remember that when you're graphing, it went 10, 20, 30, 40, 50, 60, 70, 80, 90, 120. Okay. I know that the vertex is going to be between 50 and 60, 10, 20, 30, 40, 50, 60. So somewhere here. I know that the x-intercept's right here and right here. As you can see, that doesn't look nice because my spacing is gone. Okay. I also know that 14,000 over 3 is 4,666.67 or 66 repeating. Okay. That's just interpreting. Now, when you interpret also, you have to write a sentence with it. So what we're saying is always bring it back to the situations. What that says is that profit is made between, and then I'm going to approximate that right there to 1 to 112. And then, of course, what am I talking about? I'm talking about systems. Now, when I talk about, sorry, they're about to do an announcement for us. Great. Sorry, guys, hold on. All right, the recording's over, or the announcement. Okay, now interpret the vertex. Well, what does that mean? That means that if you do 170 divided by 3 right now, it's about 56.7. So you could say that we, or who is it? The weekly profit. Sorry, guys. How do I want to say this? I didn't want to say we. In my papers, I have we. We make a max of $4,666 because we're talking about profit. Now, here's the thing, guys. Are we going to actually sell 56.7 consoles? No, we would sell 57, right? So if we plug 57 into our equation, it comes out to 4,066. Wow, I can't talk. $4,666.50. Okay, so we're going to say that we sell 57, and then at max we make $4,666.50. Excuse me. If we sell 57 systems. Now, I want to tell you that that is the max if we do that, because if you plug in 56, right, we would get times negative 1.5 times 56 squared plus 170 times 56 minus 150. If we sold 56, we would make only 4,666. Even though, yes, we can't sell 0.7, I estimated up, which is totally fine. This is why you show how you work and you interpret. Okay. All right, next page. Again, I apologize for how long this is. All right. Whew. Much to Kyle's surprise and delight, he inherits a large parcel of land in Wasatch County from one of his estranged relatives. The time is finally right for him to pursue extreme farming. He wishes to build a rectangular pasture and estimates that he has enough money for 200 linear feet of fencing. If he makes a pasture adjacent to a stream, so no fencing is on the side, what are the dimensions of the max area? Okay, first of all, drawing this always helps. So we're doing a rectangle, but you also know that this side is on a stream. So we only need these three sides. So I'm gonna label them width, length, and width. What are things we need to know? Well, we are trying to find the area, max area, which of course is length times width. Now, max area, of course, is going to be a max of our parabola. So keep that in mind. That's the vertex. And what's given to us is that we have 20 linear feet of fencing. Well, if we have 200 to go around here, that is actually our perimeter. So 200 equals 2W plus L. Okay. Now, if you look, we have two equations. We need to figure out which equation to look at. First of all, here, there are only two variables. Since there are only two variables here, this is the one we're going to use. Okay? So, what we're going to do is solve for one of these variables. Which one's easier to solve for? It doesn't matter. We could do either one. The easier one to solve for is length. So length equals 200 minus 2W. Now, what do we do with that? Well, what we do is we substitute it back in to the other equation. So the idea is pick one of the equations, rearrange it, and then substitute it in the other one. The one you rearrange only has two variables. So now when I say area equals, I'm actually going to put in this 200 minus 2W times W. I'm going to put it in front those because that's where we usually see our multiplication. Okay. Next, we want to distribute. So area equals 200W minus 2W squared. And what do we need to find the max? Well, the max is the vertex. And how do we find the vertex? Well, that is negative B over 2A. Now be careful because this is not in the order. This is B, this is A, and this is B. So be careful. Okay? So negative B all over 2 times A. If we do this out, we get 50. Okay? Now, 50 is one length, but we want to find the actual area. The way to find the area is then to substitute back in to the equation. And don't forget, this is the W part of it, right? This is a W. So we have to find the length. So we could plug it in back into here, okay? So L equals 200. Oh, no. We want it in the area, right? Because we want to find the area, not the length. We want to find the area. I plugged it in the wrong equation. So I need to plug it in up here. So area equals 200 times 50 minus 2 times 50 squared. So the max area equals 5,000. Now think of what area is. Area is squared. And then we were talking about feet. Okay, so we got our max area. That's our answer. What was our second part? It says if the average alpaca, I can't even speak today, guys, sorry, needs 25 square feet of grazing, how many can Kyle keep in his pasture? Well, if they need 25 feet per animal, we just do a division, right? So 5,000 divided by 25 means that he can have 200. So in 5,000 square feet, Kyle can have an average of 200 alpacas. Whew. All right, last part, guys. So sometimes we are asked to solve equations that are in quadratic form, or that are quadratic in form. We can use substitution and what we know about quadratics to help us solve. Okay, this is called use substitution. Some of you might have done this during secondary 3. If you were in calc, you definitely did it. So let's go with it. First thing you want to do is move everything to one side. So we get 5x squared, x to the 6th, plus 8x cubed minus 4 equals 0. Okay, one of the things I always want to point out to make this quick for you guys is that when we use u substitution, your u will always be the middle one. So I'm actually going to have u being x cubed, which makes sense now because if I plug that back in, I would have 5. Well, how do you make x to the 6th? Well, that's just x cubed squared. So I make the u squared plus 8u minus 4. And now we can factor like normal. If I'm going to factor this quickly, if you need help factoring, make sure you talk to me on the side so we can go through that. But when we factor, we end up getting 5u minus 2 times u plus 2. Now, of course, when we factor, we set each of these equal to 0 to find what we want. Now, did we have u's to begin with? No, we did not. So what's going to happen, guys, is that we are actually going to plug the x cubed back in. So 5x cubed minus 2 equals 0. X cubed plus 2 equals 0. And we solve. When we solve this, add 2, divide by 5. So add 2, divide by 5. And how do you get rid of a cube? You take the cube root. Okay. And here I would subtract 2 and take the cube root. And since it's an odd, a negative can be there. And these are both your answers. Let's try one down below and then we're all set. Okay. First, I'm going to move everything to one side. I get 1/2 minus x to the 1/4 minus 6 equals 0. By the way, remember the highest exponent comes first. 1/2 is more than 1/4. And remember what I said above, the u is your middle variable, which is x to the 1/4. Making this x, not x, u squared minus u minus 6. Again, if I square this, think of this, if I square this, I would get the 1/2. So that's where the u squared comes in. Now I can factor it. What two numbers multiply to give you -6 but add to give you -1? That would be 3 and 2. But it's a negative u, so it's -3 plus 2. Again, I'm going to separate it. U minus 3 equals 0. U plus 2 equals 0. Substitute back in before you solve, guys. So this is x to the 1/4 minus 3 equals 0. This is x to the 1/4 plus 2 equals 0. All right, let's think of this. I would add 3 to both sides, so x to the 1/4 equals 3. How do you get rid of a 1/4? Well, you do it to the 4th. And whatever you do on one side, you do to the other. So x equals 81. Now I want to show you why I showed you the steps this time. I worry because this is an even exponent. Okay, so let me do x to the 1/4 equals -2. Now be careful. What does 1/4 mean? That means it's the 4th root of x. Guys, would you ever take a 4th root and get a negative number? No, because you can't get negative numbers when you take a 4th root. Even will always be positive. So this, I can stop right there. That is not a possibility. And I get x equals 81. So when you have odd exponents, you're good. If you have even, you want to watch out. All right, guys. Thank you, and I will talk to you later.